Welcome back, cosmic explorers of the UNSS Phoenix XCS 337. Today, we're diving deep into one of the most awe-inspiring and powerful processes in the universe, the violent birth of stars and their spectacular deaths in supernova explosions. Stars are the engines of the universe, creating the elements that make up everything around us, from planets to the very atoms in our bodies. Their life cycle begins in dense regions of gas and dust known as stellar nurseries and ends with explosive force, scattering heavy elements across space. Join us as we explore how stars are born, what drives their intense energy, and how they die dramatically, leaving remnants like neutron stars, black holes, or even vast clouds of gas for new stars to form. This journey will take us through the heart of stellar formation, the life cycle of stars, and the ultimate power of supernovae. The birth of stars in stellar nurseries. Stars begin their lives in massive clouds of gas and dust called stellar nurseries, or nebulae. These clouds are mostly made of hydrogen, the simplest and most abundant element in the universe. Gravity slowly pulls clumps of gas and dust inside these clouds, forming dense regions known as protostars. As more material is drawn in, the protostar's core becomes hotter and denser. When the temperature reaches around 10 million degrees Celsius, nuclear fusion ignites. At this point, hydrogen atoms begin to fuse to form helium, releasing vast amounts of energy. This marks the birth of a new star, a glowing ball of plasma that will shine for millions or even billions of years. Cosmic fact: the Orion Nebula, one of the brightest nebulae visible from Earth, is an active stellar nursery located about 1,344 light-years away. It's home to hundreds of newly formed stars. Life on the main sequence: a star's longest stage. Once nuclear fusion begins, the star enters what's known as the main sequence phase of its life. During this time, the star burns hydrogen in its core, converting it into helium and releasing energy through light and heat. The length of time a star spends in the main sequence depends on its mass. Smaller stars, like red dwarfs, can burn for trillions of years, while massive stars burn through their fuel in just a few million years. Stars like our Sun are medium-sized stars and will spend around 10 billion years in this stable phase. The delicate balance between the gravitational pull inward and the outward pressure from nuclear fusion keeps the star stable. Riddle: what has hands but can't clap? Hint: think about something related to the passage of time. The death of massive stars, supernova explosions. When a massive star, typically one with more than 8 times the mass of the Sun, runs out of hydrogen in its core, it starts burning heavier elements like helium, carbon, and oxygen. As it burns through these elements, the star becomes unstable, expanding into a red supergiant. Eventually, the core collapses under the force of gravity, triggering a catastrophic explosion known as a supernova. This is one of the most violent events in the universe, capable of outshining an entire galaxy for a brief period. The supernova explosion blasts the star's outer layers into space, creating a supernova remnant, a stunning, glowing cloud of gas and dust that adds to the beauty of the cosmos. Supernovae are not just destructive, they are essential for creating the heavier elements that make up planets and life. Elements like carbon, oxygen, and iron are forged in the heart of massive stars and spread throughout the universe by supernovae, enlightening us about the cosmic processes that shape our existence. Cosmic fact: supernova 1987A, one of the brightest supernovae observed in recent history, occurred in the Large Magellanic Cloud, a nearby galaxy. It was visible to the naked eye from Earth. The remnants of supernovae, neutron stars, black holes, and supernova remnants. After the supernova explosion, the massive star's core is left behind. If the core is between 1.4 and 3 times the mass of the Sun, it becomes a neutron star. Neutron stars are incredibly dense. Just a teaspoon of neutron star material would weigh billions of tons. These stars are also known for their extreme magnetic fields and rapid rotation, often becoming pulsars. If the core is more than 3 times the mass of the Sun, gravity overwhelms it, collapsing it into a black hole. Black holes are regions of space where gravity is so strong that not even light can escape. They remain some of the most mysterious objects in the universe, and studying them can provide insights into the laws of physics at their most extreme. Meanwhile, the supernova remnant, the cloud of gas and dust thrown out by the explosion, can become the birthplace of new stars. The material from the dead star mixes with the interstellar medium, enriching it with heavy elements. This process continues the cosmic cycle of life and death as new stars are born from the remains of old ones. Riddle: I am lighter than air, but 100 people cannot lift me. What am I? Did you happen to know? The Crab Nebula is the remnant of a supernova observed by Chinese astronomers in 1054 AD. Over 900 years after the explosion, it is still expanding and glowing brightly in the sky. Question for you: if you could witness a star's birth in a nebula or the explosion of a supernova, which would you choose? Let us know in the comments which cosmic event fascinates you the most. Coming up next, in the next Cosmic Chronicles episode, we'll explore the cosmic web, the large-scale structure of the universe. How are galaxies connected across vast distances, and what does the universe look like on the largest scales? Stay tuned for more cosmic wonders. As we conclude our journey through the violent birth of stars and supernova explosions, we hope you've gained a deeper understanding of how stars form, live, and die spectacularly. A star's life cycle is a powerful reminder of the dynamic and ever-changing nature of the universe. Stars light up the cosmos and create the elements necessary for life itself. From the dense stellar nurseries where new stars are born to the explosive deaths that create neutron stars, black holes, and supernova remnants, the story of stars is one of both creation and destruction. The next time you look up at the night sky, remember that the stars you see are part of a cosmic cycle going on for billions of years. Riddle: the more you have of me, the less you see. What am I? And don't forget to subscribe to Crazy Frank's Crazy Video Productions on YouTube for more cosmic explorations. Stay tuned for new content and fascinating insights into the universe's wonders. By subscribing, you'll never miss an update. Answers to riddles: 1. A clock. 2. A balloon. 3. Darkness. Cosmic Comic, Space Diner Delights, The Supernova Special, Panel 1, an astronaut walks into a space diner and sits down. The alien waiter approaches with a vast, glowing dish. Panel 2, the astronaut asks, "What's the special today?" Panel 3, the waiter replies, "The Supernova Special, an explosive burst of flavor." Panel 4, the astronaut hesitates, "Will it blow me away?" The waiter grins, "Only if you're made of stardust." Cosmic Recipe, Supernova Sundae, ingredients: 2 scoops of your favorite ice cream, for a cold nebula-like base, hot fudge sauce, for the explosive supernova, whipped cream, sprinkles, for stardust, cherries, for red supergiants. Instructions: 1. Scoop the ice cream into a bowl. 2. Pour hot fudge over the top to represent the explosion. 3. Add whipped cream and sprinkle stardust, sprinkles. 4. Top it off with a cherry, symbolizing a dying star about to go supernova. 5. Enjoy your explosive dessert while pondering the cosmos. And thanks for watching.